Megan, and I'm in Science Hour 4, and my topic is going to be about stars. Star formation. Stars are created within the clouds of dust in the galaxy. It can either collide with another dense molecular star, or the cloud could be close enough to take in the pressure caused by a giant supernova. Stars can also be born by a collision of two galaxies. If this happens, heat is needed to fuel this reaction. A protostar is the size of a newborn star. Small protostars will never have the energy to be anything but a brown dwarf. A brown dwarf is about the size of a supersized Jupiter. Medium to large protostars have several paths depending on its size. If they are smaller than the Sun, they undergo a proton chain reaction to give hydrogen to helium. If the protostar is larger than the Sun, they undergo a carbon-nitrogen-oxygen cycle to convert hydrogen to helium. The difference is how much heat is involved. The life cycle of a star depends on how quickly the star consumes hydrogen. Red dwarf stars can last hundreds to billions of years, but supergiants can consume most of their hydrogen within a few million years. Now I'm going to talk about red dwarf stars. Red dwarf stars are typically smaller than an average-sized star, which means the star has less mass. These small stars burn their fuel very slowly, which means the star will live longer. But the cause of the burning fuel causes the star not to shine as bright. The color of a star determines how hot the Sun is. Blue being really hot, yellow is not as hot as blue, but is hotter than a red-colored planet. So think of a fire. Blue is usually the hottest part, on the bottom, and yellow is in the middle, so it's not as hot as blue, but red is the lightest because it's on top. The red dwarf star is the most common star in outer space, but red dwarf stars are not common when people look up in the sky. Here's a picture of a red dwarf star. It's not as big, but in outer space it actually is bigger than this. This is in life size, but it's pretty close. Okay. Now let's talk about supergiant stars. A supergiant star is the exact same thing as a giant star, only 10 times bigger than the giant star. So it's like, this is the giant star, and this is like the supergiant star. It's huge compared to the giant star. So when the star gets older, it runs out of fuel. And when the star starts to run out of fuel, it starts burning out. If the Sun were replaced by a supergiant star, it would extend from the center of our solar system almost all the way out to Uranus. That's really far. Dead supergiants often turn into black holes. The supernova blasts away most of the star. Anything left behind begins to fall into the middle of the star. It gets more and more compact and smaller. If there's enough of the star left after the explosion, the star will be heavy enough to squash it down to the size of an atom, or even smaller. Here's a supergiant star. And of course, it's much bigger in outer space. I'd say like 100 times bigger. But yeah, they're red, the color red. And yeah. Okay. Now let's talk about a blue giant star. Blue stars are large and compact. This causes them to burn their fuel quickly, making their temperatures very hot. These stars often run out of fuel in only 10,000 to 100,000 years. Blue giant stars are very, very, very bright. Even though blue giant stars are very rare, they make up many of the stars we see at night because they shine so brightly. Blue giant stars die in a very different way than the other stars. They keep growing and growing, and they don't shrink like other stars, and they explode into a supernova. Because blue giant stars only live a short time, scientists use them to find places in outer space where new stars are forming. Here is a blue giant star. It's really, really shiny. Yeah, in outer space it'd be much, much more bigger again. Like, I'm gonna say that, and it's kind of obvious, and it's very bright if you actually look at it closely. So yeah. Okay. Now let's talk about the yellow star. The yellow star is yellow, as you can tell by the name of the star, which means the temperature of the star is not as hot as a blue star. These stars don't live as long because their fuel burns faster, which means they live up to 10 billion years or more. Near the end of the star's life, the star swells up, which causes the star to grow bigger and bigger and bigger. Planets as big as the sun and as hot takes a really long time to cool off when it dies. Did you know that even when the sun dies, it's still going to go for a couple more years? The yellow star is about the size of the sun too. And here's the yellow star. It's yellow. It's quite similar, I think. Okay, now let's talk about the last star. The last star I have is the giant star. As the giant star gets old, it starts to run out of hydrogen fuel. Giant stars is about the size of the sun. So basically the giant sun, it's the same size, same color too, I'm probably guessing. So yeah, when the hydrogen fuel runs out of fuel, the core of the sun begins to slow down and the core gets more compact and dense. When the core gets smaller, it gets hotter. When it gets hot enough, it will burn a new fuel called helium. Did you know many of the stars we see at night are giant stars? And yeah, that concludes my topic on stars, and I hope you guys learned something. Thank you for watching.